Hi everyone, welcome to the first PowerPoint of Science Quarter 1. For this first quarter of Science, we're gonna do volcanoes, or as I noticed, volcanic panic. Volcanoes and how they work. But first, we should ask, what's a volcano? Ooh. You see, volcanoes start out as regular, boring ground. That is, until an event called earthquakes happen, and it sometimes which shakes the ground, either thrusting it upwards or tearing the ground into two. From the mountains, there could be a chance of a little something called lava which bursts coming through and bursting from the top, creating volcanoes. These three events, the earthquakes, the splitting of the ground, and the lava going through the mountain, are all caused by something called tectonic plates. But wait, why does tectonic plates cause disasters like earthquakes, and what are tectonic plates exactly? Okay, to understand that, we first need to understand the three layers of the Earth. It's starting with the crust, as every living thing on Earth lives on the topmost layer, which is where we are right now, the crust. The mantle is in the middle, which is split into many sections that's at least sandwiched in between the crust and the core. And speaking of the core, it's the final layer of the Earth, and it acts as Earth's center. It plays a crucial role in the magnetic field of the Earth and in moving the plates. Okay, but now seriously, what are tectonic plates supposed to be? Well, you see, since we live on the crust, and the crust is divided into many pieces like a jigsaw puzzle. These pieces are called tectonic plates, and these are moved by the mantle and convection currents. However, when they move very slowly, like even slower than a snail. But despite their slow speed, tectonic plates have a very special interactions with one another. These are called plate boundaries or plate faults, and the one that can create volcanoes and erupts them that are called convergent plate boundaries. Let's start the eruption plate prep. So, when a convergent plate boundary occurs, it causes two plates to crash into one another. They're like this. As they crash into one another, one gets abducted or goes underneath the other. And when this happens, it creates a force so strong that it causes earthquakes. And the earthquakes can sometimes create mountains and even volcanoes. Because when volcanoes form, they start out as mountains, which could have started out as ground that was thrusted upwards by the converging of plates. But ground wasn't the only thing that tectonic plates pushed upward when the convergent plate boundary occurs. It also pushed up this. This is something called magma, which is the melted remains of rock. Yes, magma is what happens when you melt rock, and it's not called lava until it reaches the surface. Now, the magma, which is underground, would start filling up in a place called the magma chamber, which is underneath the mountain. Eventually, if enough magma gets into the chamber, it would create enough pressure to force the magma upwards and boom. So, once the convergent plate boundary was complete, the magma would have enough pressure or enough magma to rise through the mountain until it reached the top. This would form something called the summit crater at the very top of the mountain and turn the magma into lava. And thus, these events are the main reason for why volcanoes erupt like this. As you can see, when the plates converge, they sometimes push the ground upwards, as well as magma. And magma goes into the chamber, and if enough gets to the chamber, it all goes boom. Boom. Now, so the next time you think about volcanoes, remember everything that created them, from the crust, to the mantle, the core, the plates, and the magma that creates volcanoes and makes them erupt. Now, there are 4 types of volcanoes you'll find. There are cinder volcanoes, which are created... So there are 4 types of volcanoes. Cinder cone volcanoes are created from when lava blobs of a single eruption of a volcano end up hardening around the volcano. It makes a cone shape near the central crater. A shield volcano is similar, but instead of one eruption, it makes multiple repeated eruptions that go pretty far, creating a shield shape. Stratovolcano is the most common type of volcano, and it's created from repeated eruptions from centuries to a millennia. And yeah, as the years go by and the volcano erupts every now and then more lava is turned into rock that's added to the volcano, making it a lot steeper. And finally, we got lava dome. You see, when lava that doesn't flow very well will get stuck near the vent and in the volcano, it causes something called a lava dome to form. And this is very dangerous because as the not so flowing lava can also be followed by explosions of lava. So if that starts happening, you better start praying badly. All right. And now here are some examples of volcanoes in the Philippines. Means these 3 volcanoes which I have chosen are all found here in the Philippines and are all stratovolcanoes. They include Mount Pinatubo in the Zambales Mountains of Luzon, Mount Taal in Batangas, and Mount Mayon in Albay. Note, Mount Mayon recently erupted a few months ago, as it's actually one of the most active volcanoes in the world, erupting every now and then. And now that we've gotten the talk of volcanoes out of the way, we can get to something that probably a lot of people who've done volcanoes have done. Made their own homemade volcano. For this quarter, I made a volcano using this National Geographic Build Your Own Volcano kit. If you own this kit or want to try making your own volcano, I've recorded the entire process so that you can follow along. Step 1. Build the kit included volcano mold. This is important for later. Yeah, so in the kit, there's these 3 pieces as well as this base. Put the 3 pieces into the base and connect them together, and then put a rubber band to connect them. Note, be careful because the rubber band is actually very, very hard to put on. Like that. Like that hard. Now we go to step 2. Mix the kit included plaster with water until it reaches a consistency. Or more specifically, until it reaches a state where it's flowing like water, but not too watery and not too viscous that it doesn't flow. So when you add the plaster which came in the kit with the water, make sure to mix it just right, so that when it goes out, it's not too watery like water and not too stiff that it won't flow into the kit, into the mold. No, mixing could take minutes. Quite a few minutes. And a few attempts to do. Oh, but eventually, you'll get it. Okay, step 3. Pour the plaster into the mold and wait for it to harden over a few days. If you made the plaster correctly to a point where it's watery but not too watery and not too stiff, place it into the mold and then place it into the mold right here and wait for it to harden for a few days. Like give or take maybe 3 to 5 days, maybe perhaps or at least a week. In my personal experience. Yeah, so once they're all inside, hey, wait for a while for it to harden. Once it's fully hardened, take it out of the mold and start painting. Here's to your right, you can see what the volcano is supposed to look like if done correctly, and also it's looking pretty bland. For this part, you can color your volcano. However you like at this part. But for the sake of consistency, I drew it exactly I painted it exactly how you'd see a regular volcano. Black with red and yellowish oranges flowing lava coming from it. Wait for it, and yeah, that's what the volcano should look like. Now, once you're done painting the volcano, you gotta add in the eruption powder that came in the kit. There are 2 bags of this. Mix them together to give yourself the eruption powder needed for the eruption. And then, but before you add the eruption powder or mix it, wait for the paint to dry. Because this might ruin the paint. You'll see why in a minute. So after waiting for the paint to dry and making the powder, add a spoonful into the volcano, and then add the water and watch it blow. And 3, 2, 1, hit it! Like that. You can make... that's what it's supposed to look like. I'm feeling like it should be more, but that's the best one we could make. And so with that, that's all. And that's my homemade model volcano. Now, just in case, here are 3 questions you might have about volcanoes that I can answer. 1. How does the mantle and convection currents move tectonic plates? The best way to describe this is think of tectonic plates as a boat and the mantle as the sea. The tectonic plates flow along the mantle like a boat does on the river or the sea. Yeah, and convection currents are created from heat, which can come from both the core and the mantle. So the convection currents also help push tectonic plates along during this step. 2. How does magma get into the magma chambers? This is simple. You see, when magma is heated by the core of the Earth, it causes it to rise upwards, and eventually it reaches the crust. It's after getting through the less dense rock, it gets itself into the magma chamber and then waits for enough magma to pour in. Once enough pours in, then boom goes the volcano. And then finally, question 3. What are other interactions between plates beside the convergent plate boundary? Oh, that's simple. There are 2 other kinds of plate boundary or interactions. That being divergent plate boundary, which has as the plates split apart, and sliding/transform plate boundary, which has 2 plates slide next to each other like this. When they do that, they sometimes create a force strong enough to make earthquakes and volcanoes like the other two plate boundaries. And with that, that's my PowerPoint. Yeah, and here are the sources of information. Thanks for listening, everyone, and until then, see you in the next PowerPoint. Bye!